So in this problem, we know that there's an airplane, and it has a heading of 140 degrees, and it's flying at 430, and there is a wind that is blowing from 160 degrees at 60 miles an hour. So the first thing we need to do is set up this compass so that we know exactly what's going on. So here, let's draw on our compass. The airplane is pretty easy. That's 140. So the airplane is here at 140, almost like there. And the wind is coming from 160. So 160 is like here. But it's blowing from it, which means it's blowing that direction. So this is the wind. Let's see, if that's 160 over here, that means this is 20 degrees. So this is 20 degrees. And it's blowing at 60 miles an hour. So because both of these things are at angles, I am going to change them into their vector components. But first, let's see. If I were to put the 60 here and the 430 there, that means that my plane should be flying something like this. So that's what I'm going to be looking for. Now the angles are kind of tricky to figure out here, which is why I'm going to use vector components rather than trying to use a law of cosines. So bear with me while we do this. So we have the plane. The plane we're going to change to the vector 430 times the cosine at 140 and 430 times the sine at 140. Okay, so I'm changing the vector into its vertical and horizontal components. So this is the horizontal component, this is the vertical component. Okay, so we should know, because it's in the fourth quadrant, that both of these are going to be negative. So no, cosine is going to be positive, so the x will be positive and the y will be negative. So let's see what we get when we plug this into our calculator. 430 cosine of 140. That should be a positive 329.4, even though it says negative, because cosine at 140 is negative. And 430 sine at 140 needs to be negative 276.4 itself. Okay, so when we're using component form, you have to make sure to get the signs, the positive and negativeness of your x and y correct. So now let's look at the wind. Okay, the wind is going to be, let's see, how fast was the wind? 60 miles an hour. So we're going to use this angle, the angle formed with the x-axis, in order to break our wind into its components. So 60 cosine of 60 degrees and 60 sine of 60 degrees. Now because it's in the second quadrant, the cosine should be negative. So negative 30, because it's in the second quadrant, and cosine is negative there. And 60 sine of 60 becomes 51.96. So let's just call it 52. Pretty close. So that's my wind vector and my plane vector. Now I'm going to add these two vectors together. So my wind plus my... So 329 plus negative 30 is negative 299.4, sorry, positive 299.4. See if I can erase that. There we go. And negative 276 plus 52 is negative 224.4. So when you're doing this method, it's really important to make sure that you get the signs of the x and the y coordinates correctly, or you're going to be all kinds of crazy. So now we find the resultant, which is done by Pythagoras, square root of these two numbers squared. And it's okay if we just make them all positive. Squaring things makes them positive anyway. So that's why I have not negative 224, but positive 224, because squaring makes them positive. And this gives me a ground speed of 374.2 miles per hour. So that's the ground speed of this plane. Okay. So the next, oh, that's kind of small. The next thing I want to do is find the course. So to find the course of the plane, I'm going to use the inverse tangent of the y value over the x value. So tan is always y over x. So we do inverse tan, 224 divided by 299. I get an angle of 36.9 degrees. Now, you need to remember that this angle is the angle formed with the x-axis. So this angle is the 36.9 degrees. And that's just ugly. When you use the inverse tangent, you always find the angle formed with the positive x-axis, or with the x-axis period. So I have to add 90 degrees to this in order to make it into the fourth quadrant, which is 126.9 degrees.